now we're 3 segments long, right? And it's following because our head is basically pulling, and then each segment moves to the previous position of its parent. Welcome back to Arcade. I am Super Tommy, and this is part 2 of our building snake in Kaboom.js. Now, in the last part, we created our head, snake head that moves around. Let me refresh it. It moves around. We can control it by using the arrow keys to change the direction of where the snake head is going. And then we started adding food, this blue square here. So you see that it doesn't actually eat it when it runs into it, and it's off in a slightly wrong grid location. So in this video, part 2, we're actually going to handle putting it on the right proper grid space and handle collision, and depending on how far that takes, we're going to do the hardest thing in making snake, and that is making sure the snake pieces follow our snake head in that proper manner where everyone is delayed about 1 move from the parent itself. So before we get started, be sure to hit like if you enjoyed this Kaboom and Snake series, and subscribe to our YouTube channel for more videos on making games with Kaboom and other web technologies. So now let me make myself smaller so we can get started here. So first of all, we put our food spawner, this is our spawn here, at 128, 128. Now that is correct if that was the top left corner. So we actually want to, of course, +8 to both of these so that it's on that 16 by 16 grid. But instead of doing that here, just to show you, we're going to actually use a random position generator that puts you on the correct tile place just randomly. So let's make a utils folder here. So we're going to put it at the source, at the root of the source folder here. We're going to call this utils, and we're going to call this get random position. And we're going to use this probably more than once, so we're going to make it a function here. And so what we want to do here is import Kaboom, and then we're going to export a function like our components and our scenes, but this is not going to be used that way. Get random position. And so what this is going to do is we're going to take the width of our entire game and the height. We're going to divide that by the tile width and tile height, which is going to be 16. And then that's going to give us a floating point number, most likely. If it's not, then that's perfect. Then we have our correct, like if our width is a multiple of 8 or 16, I think in this case, then the numbers will divide perfectly. But if it's not, then it won't. So we can just floor that so that we get, whatever decimal, we can just remove it and just take the integer part. And then we're going to then know how many tiles are going to be across and down. We're going to randomly pick one of those, multiply that back by the tile width and height to get our pixel location. So there's tile location and there's pixel location, and that's how we're going to give a vec2 after that as the position. So that's the theoretic. So let me just show you how to do it in code. It'll probably make more sense if I did not explain it very well verbally. So let's do this here. So we're going to return a vec2, so we're going to need that. Then we're going to want to know the width and height of our game canvas here. And then we're going to use Kaboom's rand. Okay, I should have done this first. So if you didn't watch part 1 and you're watching part 2 for some reason, if you do this, you can then get help from VS Code via the typing file. So we want width, height, and we want the rand function from within Kaboom itself. So let's actually say we take in a tile width and tile height. So this is tile W. We're going to default it to 16. That's what we're using here. But just to make this a little more flexible, let's collapse this. So it's tile width, tile height. So now we want to get the total number of tiles. Let's call that, let's call this TX. Total number of tiles on the X axis. And so we want to know width divided by tile W, right? So if it is 16, and let's just say your width is 32, then your TX is going to be 2. But we have, of course, a much bigger canvas here. and it may not be always in multiples of 16. So it could be like, you know, like 10.036 or whatever it may be. But we don't care about that. We're going to just do math.floor to get the minimum number of tiles going across. Let's do the same thing for the y direction or the vertical direction. So we want to do math.floor, and then we're going to do height. Height divided by tile height. So of course, if your tile height is 64, if your height is 64 and your tile height is 16, then you'll have 4 as a total. But once again, just like on the horizontal, the x-axis, it could be a floating point if your canvas is just not a multiple of 16, so we're going to just floor it. So this is the total number of tiles across and the total number, total number of tiles up and down. So once we have that, we can do a rand between 0, which is going to be, you know, the 0th tile over here, and then, you know, whatever the maximum tile is based on what we just calculated. So we use rand, and rand is going to give us a number between 0 and, like left. So let's just use some IntelliSense here. The options we have, oh, it's not, let's go into it. The options we have, come here, in rand, is A and B. So the left side value and the right side value. So that means if we do 0 and 10, it's going to be a value between 0 and I think 9. So what we're going to do here is 0 and then tx. So this is going to be the x. And it's going to be a float as well. So we really only care about the whole number. So we're going to do math.floor for this guy. So this is going to give us a number between 0 and tx could be 10 or 12 here. This may actually be like 16 or so. So once we get in between 0 and 16, we're going to take that number, so let's say it could be 5, multiply that by tile width. This gives us the pixel location of wherever that is, because each tile is 16 pixels and we want the 6th pixel or 6th tile, so we do 6 times tile width to get to that pixel location. And since we're using origin center, we're going to actually add tile width, the half tile width, which in our case is 8, and so that's going to be x. So now y is very similar. Math.floor, we're going to also do rand, we're going to do ty, then we're going to multiply that by tile height, and then we're going to add tile height times half. We're going to return that out as a vec2xy. So there we have a random position on our game here in our 16 by 16 tile size grid. All right, now let's go back to spawn. And now let's import our get random position from our utils folder. And now instead of doing 128 by 128, the position component also takes a vec2. So we just do this. Get random position. We don't need to pass in tile width, tile height. And you see, that's our food. And it's going to align perfectly with where our snake is going because we're all in the same grid now. Okay, so we got that. Food spawns. Now we need to actually know how to overlap between the head and our food. So first thing we're going to do while we're in the spawn anyway, we're going to tag all of our food components a food tag. So any string passed inside add here is going to be treated as a tag. So we're tagging everything that's spawned as food. And then over here, we're going to make our head here. We're going to tag this head. So this is the head of the snake that's going to be eating. And then we're going to use overlaps. So that's a function from Kaboom to tell you when two game objects have overlapped of a certain tag. So we're going to check head overlaps food. It's going to give us game object A, which is going to be head, game object B, which is going to be the food that was overlapped with. So first thing, of course, is we're going to destroy the food. So we take destroy from Kaboom, we're going to do destroy food. Let me just check some notes here. cool. Let's try it. And this should go away. Boom. All right, so it ate the food. We can also do something cool here since cam shake is built into Kaboom. We'll just do a little cam shake when that happens, just to add a little flair, let's say. And shake. So, looks a little bit cool. You know something happened when you ate the food. It didn't just like nothing happened. Okay, so now once we add the food, what happens in Snake is we need to create another segment and then add that segment to the snake. So of course our snake is only one square right now. So we're going to use a linked list type system to make the snake basically follow, and we'll know what each child of the first node is. In this case, the head knows its child node, and that node knows its child node, and we're going to just append pieces of the snake as we eat food to the end of our linked list like structure. So if you're not familiar with linked list is basically what I described. It starts with a node, he's got a parent to a child, and then you can then of course go down from the parent to the child until you find the node you're looking for, if you were doing a search on this list. But it's basically an infinite long list with chains, like a chained list. If you are curious more about basic data structures, do let me know in the comments below. Okay, so now here we're eating a food. We're going to create a new entity, and it's going to be very similar to our head here, because it's going to be a rect, it's going to have color, it's going to be center, but it will not move and it will not have controls, right? Rather, it will move, but it won't have controls. We're not the ones moving it, and it's not really moving in the same way as this movement component where it has a direction and it's going to move. We're actually going to make it so that we need these three. We're going to make it so that the head pulls everyone along. So we got that. We do need a position as well. Now the position, what we're going to do is when you eat food, we're going to put a new square where the tail of the snake is. So when you have one segment, the head, that is also the tail, or the end of it. Let's not call it a tail. There's the head, and then there's the end, and then in between, you can call that whole thing a tail. So there's a head and there's an end. And when you start, the head is also the end because there's only one piece. So let's go here and store this as the end. It starts off as the head, but it is also the end. And what we're going to do is put this new piece at the end of the snake. So end.position.x, end.position.y. Right, so you eat a food, we're going to create a new square and put it wherever the end of the snake is. When the snake is long, the end will be different. When the snake is short, it'll be on the head. Short as in one. Okay, and let's leave it like that for now. So the snake will run into it and it has to handle a game over situation. We'll cover that afterwards. So let's just do this so that we see that we add a square somewhere on the screen after you eat a food. Let's go here and boom. Okay, so we put a square at where the end was. So let's here call this new child, or new body. Let's call it new child. And what's going to happen is when you create a new end, right? Basically, this is the new end. You're going to have to set end to this new child. So let's say end gets new child. So now that you have a new place for where that end is, although this doesn't show you anything, I just disencoded, but I got distracted when this thing started moving. So now end is this here. So the things that we don't have yet is we want this thing to follow our snake head. And then next time when this happens, you eat a food, when you eat it, the end is here. So it's going to put another thing there. So let's actually do all of this, and then we're going to spawn a new food. So spawner.spawn. So maybe this can demonstrate what's happening. So we're going to eat this food, and you'll see the next green piece shows up where the snake was, right? Okay, there. Now, it showed up where the head was. Now, if we go to this other food piece, it should not show up where the snake head is because the snake head is no longer the end, right? It didn't, because it actually is two rectangles over here. So that more or less proves that conceptually that works. So now what we want to do is add some linked list functionality here to our snake movement system. So let's do that by adding a new component called link. Let's go here. There may be a better name. I'm just going to call it link.js. Let's check my notes here. Okay, first thing, we want Kaboom as usual. Kaboom export a function. We're going to call it link. And like all our components, we return an object. Okay, so this is a linked list-like structure where I was mentioning you have a child. You basically reference a child. Every link, every node references a child. So first thing you're going to need, of course, is a child. Let child, right? Not new child, child. You want to at least know that there's a child, and then you want to be able to get that child because you want to know if you have a child or not in some cases. But you definitely want to be able to set that child, right? And then we'll do child.c. So basically, every time a new segment is added, the end is going to set the child to the new child that we created when the food was eaten. And then what we'll do is, when you move, we're going to pull everyone along with us to the position that the parent node was last in. So we're going to need to know our previous position. So let's keep track of that. And we're going to actually want a vec2 here. So vec2. Let's say const previous position vec2. And we're going to start it at 0, 0. And let's say when we add, we're going to set the previous position to whatever our position is at the time. We may not actually need this, but let's just add that there so that it doesn't stay at 0, 0, because 0, 0 is definitely wrong, or most likely to be wrong. Just using whatever the position of our created entity was is more likely to be correct. And then let's just say we have a function that's going to get called each time the head moves. The head moves, it tells its child, okay, move to my previous position. And then that node is going to then call its child and say, okay, child, body, move to my previous position. And all the way down until we reach that we have no more children or no more child at the current end of the snake. We'll just call this move update, and we're going to give it an X and a Y coming in here. This is the previous position of the parent. So we want, first of all, to save our previous position, because this is like recursive, so this may get confusing. But as the parent, I want to know what my previous position was. Save that. I'm going to give it to my child after I moved myself, right? So let's just call this that previous position.clone. So there's a clone function on our vector. Let's collapse this for more space. So we save our previous position. We do clone, and we don't just do a reference. So like, for example, this doesn't work. That just means position points to previous position and previous position points to itself. We want to make sure we do a clone. And we want to now set a new previous position for ourselves. Let's see, which is the position of our parent, let's say. Hopefully I explained this correctly in the beginning. But we'll see. I'll re-explain this after we have it. Now we want to move ourselves to our previous position. Make sure that is actually correct. And if we have a child, so if not child, don't do anything. If we have a child, we want to child.move update. We have a child that has a move update. We're going to do .x, repl.y. I may have explained it slightly incorrectly, but conceptually similar. Okay, move update, we get an x and y. This actually may be the x and y of our parent. Recursion is confusing. We come in here, we clone our position, we save the incoming xy as our previous position, we move ourselves to our previous position. And then if we have a child, we update the child with our previous position. Let's see what this does. Okay, so we have this link function, link component. We come here. Let's do this. Import spawn from components, not spawn. Import link. Okay. Now every node in our snake is gonna be a link. So we'll add a link component to our head, and we'll add a link component each time we create a new child. So end is the new child. But before we do that, end.setChild is going to be the new child. Okay, so let's just walk this through. When we first start with the head, we are one thing. We come and make a new child. End is the head. We set that child to the new child. So now head, new child, they've got a link to each other, or rather, the head has a link to the child. Now we set the end to our new child, and we all have a link. And to make it so that we can call move update in our movement component here when we are moving, we want to keep this in this place just because our accumulated time here, we're basically throttling the update here. So for our snake, keeping it here is easiest. So we're going to do, let's just check for a child, this.getChild. And if we don't have a child for some reason, don't do anything. And then child.moveUpdate. Let me just double check my notes to see what I intended to move. So we're going to give it the position of our new position. Okay. Boom. So that's our new position. Let's come here. And there's our snake. It's now 2 segments long. Need a third one and see how this goes. And now we're 3 segments long, right? And it's following because our head is basically pulling, and then each segment moves to the previous position of its parent segment. All right, now let's just walk this through. But what we're doing here so that we have a clarity on how this algorithm works, I guess. So in each update, if there is a child, so if you're a link node, we have a child, we call move update, and we pass it the current position of our head node. So let's go to move update on our link component. So it comes here. This is the current new x and y of our head node, which is going to be the position we go to next. So calling this previous may be what is confusing. So I actually rename this to rename symbol next position. So next position is going to be the incoming. So if your parent is moving to 1.1, right, let's just give a different number. Your parent is moving to 128, 256. You want to move there next. So we're going to clone where you were at, or the previous next position. We're going to change the current value of next position to where your parent is now. Then we're going to move to where your parent was, which is this. And then if you have a child, you're going to give it your current position, just like the head gave you its current position. So your parent gave you its current position, you give your child your current position, and you store your parent's current position and use the previous position that your parent gave you. That's what we're doing here. Maybe this makes more sense calling it next position. Now if that didn't make sense, just rewind and re-listen, or I'll just reiterate it again. The head, in this case, when it runs when it has a child, so we're going to eat this food, it gets a child, and on move it's going to send the child where it is. The child saves where it is as the next place that it should go, and then it's going to move itself to the previous last place, or the previous next place that it's supposed to go. And then, so now it's in its parents' place previously. Now it's going to tell its child, okay, the next place you should go is where I am at now. And then the child just does the same thing recursively, goes to where the parent told it was a frame ago. And so you have this effect where the head moves and every child moves basically one frame behind its parent. Pretty cool. So now you have this snake and it's following. You can make this as long as you need. So now what we do need to do is handle the situation where it ran into itself, and then of course it should game over there. So now we're going to show you how to go to a different scene and restart the game in the next videos. Now if you enjoyed this video and you learned a bit about how to make Snake, the mechanics of creating the snake movement, do hit like on this video and subscribe for more videos on making games on the web. Come back for part 3.